at other end as shown. Find reaction at hinge and tension in the string at equilibrium. Okay, no. So what are the forces that will be acting? So just directly get into the problem. M1G, M2G, and here the tension T. This much here, no? Then this M2G, in fact here, a normal contact will be there. Huh? And this normal contact will be acting on the rod. And what is further M2G, I have to show it. I don't have space here. So here I'll put it block here. On the block, things are like this. That N2 will act, not M2G. The normal contact between the block and the rod will be acting here. How to get the reaction? The reaction on the rod here will be Rx. Sir, how you predict Rx and Ry? Rx will assume towards right because the tension, the string will try to push the rod, the hinge will push the rod towards right. And what about Ry? I'll assume it, I'll calculate Ry. If I get negative, I'll change the direction. This is Ry and Rx acting on the rod. Now, if you getting confusion only on the rod, you show it. This is a rod. This is the Rx. This is Ry. This is a tension. This is N2. MG. And get into the problem now. I think you can manage. Okay. Now it's in equilibrium. So what you can do? You can equate forces along X, along Y. So let this be theta as given. So first we'll equate the forces. Summation of net force on system along Y axis should be 0. So on the rod, Ry plus T cos theta, because this will be the theta, no? Ry plus T cos theta minus M1G minus N2 equal to 0. And we know N2 should be equal to M2G. So putting this Ry plus T cos theta minus M1G minus M2G. Or what is Ry is equal to? Ry plus T cos theta is equal to M1G plus N2G. How many unknowns are there? Rx, Ry, and T. One equation I got it. Another equation is needed. Along x-axis on the rod, Rx must be equal to T sine theta. There's the equation 2. No, I think I need at least one more, no? So what shall I do now? I'll go for talk about which point. Talk about how you take it, no? So that Ry, Rx are unknown, so that two unknowns will get eliminated. The two unknowns will get eliminated. So from here, talk about axis passing through and perpendicular to plane. Due to weight, M1G L by 2 should be clockwise. Due to N2 into 3L by 4 clockwise. What about the torque due to tension? How to take that one? T sine theta will act along the rod. T sine theta will act along the rod. T cos theta will act vertically up. Am I right? T cos theta will act vertically up. So therefore directly, to make problem simple, T cos theta into L anti-clockwise. You can do one thing. So no, sir, I'll find out angle between T and L. They'll be lengthy, no? T cos T sine theta will intersect axis of rotation. T cos theta will set up a torque. So now what is N2? N2 we know equal to M2G. This is equal to M1G L by 2 negative. N2 is M2G 3L by 4. This is also negative. Plus T L cos theta. L will get eliminated. So we'll get tension T in terms of M1, M2. That value of T will substitute, you'll get Rx. This will be M1G by 2 plus cos theta is needed. This value of T is put in equation 2 and equation 1 will get Rx and Ry. Every problem, whenever a rigid body is suspended, you must focus on the reaction. I'm telling this is very important because we do have many good concepts related to this reaction at the inch. Is something very important. That's why in every numerical, we're all suspended. I'm from the beginning only, I'm introducing here. Say if you find very difficult, break up the rod, show the rod like this. Then write all the equations. Sir, shall I take torque about point A? Yes, you write it. Tau is it. Torque about point C. Torque about point P. Anything you can write it. Let's take one more. Sometimes you get a situation of kind like this. You may find very difficult, but you have to put effort.